Okay, so we are now going to talk about logarithmic functions. Okay, and so the startup just for dealing with logs and kind of their formatting and stuff. So a logarithmic function has a base b, and it is written y equals log. That base or that b value is going to be subscripted, so it's going to be written smaller and a little lower, and then the x is back regular size. And this is equivalent to b to the y equals x. So we're going to talk about how to, because one of the things is you're going to need to be able to convert back and forth between these two formats. Okay, now b is still going to have to be positive, so it follows the same rules as our exponential stuff. It is to be positive, so bigger than 0, and it cannot be 1. Okay, now the only other restriction here is x is going to have to be positive this go around. Okay, one of our kind of math commandments is you cannot take the log of a negative number or 0. So those two are kind of off limits. So we're going to talk about changing from logarithmic form into exponential form. Okay, so we're going to talk about how to change these up and move these around. And then we'll also talk about how to get it from exponential into its log format. Okay, so we're going to see several examples here as we're processing. Okay, so the first one that we're going to deal with is going to be log base 7 of x equals 3. Now, the first thing is we're not worried about necessarily solving this. We just want to get it into its other format because our brain does not process well in this format. So we're going to switch its format. Now, because I'm in log form and I want to go to exponential, I'm going to use an E shaper, okay? So what I'm going to do is I start with my pencil on the base. I'm going to loop through and make kind of a cursive E. So the first thing that my pen was on was the 7. The second thing that I hit was 3, so that's going to be my exponent. I'm going to write my equal sign, and then it's the last thing. So this is the equivalent exponential format, okay? And if you go back, we had y equal log base b of x was equivalent to b to the y equals x. Notice, okay, there are a couple of different spots here, but my b is here, so 7 is there. Y is my exponent, that's what it was equal to, that's 3. And then x was out here on the outside edge. Now, this is one of those things, it's a nice little trick to be able to process over. Now, oftentimes we can think about exponential stuff easier. I can do 7 cubed, okay? Whatever number that makes me, I can figure, okay? Whereas my brain does not necessarily process over here. Now, it does not matter where they put kind of the letter, or if there are any letters at all, the process still stays the same. So this would be b squared equals 25. And again, if I was asked to solve this, I could now figure out what that number is going to be. Okay. Next one we've got is log base 4 of 26 is y. And again, I'm going to do my loop-de-loop. Now, notice in all of these, I am keeping my log thing written first and then my equal sign and what's going over. It just makes that e-loop a little bit easier. So I have 4 to the y equals 26. Now, not as straightforward of a thing as we have here because 4 doesn't have a clean power that goes to 26, but we could still start to try and work with that. Now, the other thing that we are often tasked with doing is we've got to go from exponential into log form. There are certain things that we're going to see in a couple of videos, further out from here about where doing some stuff with math is a little bit easier if it's in log form and has a log word as opposed to its exponential format. So we want to be able to go and get something in its exponential format into a log form. So the way that we do this, okay, is we want to go to log form. So log starts with L. So I'm going to use an L, and this is going to look like a block-shaped L. Okay. So I'm going to start with the word log. The first thing I hit was 2, so that's going to be my base. The second thing I hit was X, so that'll go next. Equals, and then the last thing. So this is the equivalent log format to this. And you can see here that if I loop-de-loop, if I did my little e-loop on that, I would have 2 to the 5th equals x, which is what we had here. So looking at, I've got b cubed equals 27. Again, I'm going to put my block form, my block L formatter. So I've got log base b of 27 equals 3. And then we've got one more, e to the y equals 33. So here we go. My L shaper. So I've got log base e 33 equals y. Now, this log base e, this is not the traditional way that this is written, but for right now, because all we're doing is converting, we're going to leave it. We'll talk more on this here in just a bit, okay? Now, they are going to ask you sometimes, now this was just the basic thing, is to actually evaluate or get some answers for some things. And more often than not, it is going to be that they give it to you in log format and are asking you to convert it over. Okay, so we'll take a look at a couple of these. So I've got log base 10 of 100 equals x. So again, I'm in log form. So I'm going to do my loop-de-loop. So I've got 10 to the x equals 100. So thinking about my powers of 10, 10 to the first is 1. 10 squared is 100, so x is 2. Okay, so I've got log base 5 okay, so I'm going to put this through equals x, and I'm going to loop-de-loop. So I've got 5 to the x equals 1 over 125. Now, if we remember our exponent rules, we know that the way that I go from a whole base or a full number base to a fin is it's going to have to be a negative number. So x here is going to have to be negative. And so now I'm thinking of powers of 5. So 5 to the first is 5. 5 squared is 25. 5 cubed, which is 5 times 5 times 5, is 125. So x is going to be negative 3 for that one. Okay, so let's take a look at another one. Now, if they don't give you the equals x part, go ahead and write equals x, because I'm going to need to have all of those parts and pieces so that I can do my full loop. So here we go. So I've got 36 to the x equals 6. Okay, now you may be thinking, hang on, I'm going from big to smaller. Okay, but it's not a fraction, so it can't be a negative. These are now going to be done with our roots type stuff. Remember that roots are done as fraction exponents. Go back and look at checkout section 1.6. Okay, it's going to be in those other types of equations when we talk about roots and powers forms. So I do know that the square root of 36 is 6, and square root is written, so square root is a 1/2 power. So x here is going to be 1/2. Okay. And then we'll do one more. I've got log base 3 of the 7th root of 3. Okay. And again, if they don't put equals x on it, go ahead and write it on there. I'm going to do my little loop. So I've got 3 to the x equals the 7th root of 3. Now, I'm going to rewrite this, okay, as that fraction power. So I've got 3 to the x equals 3 to the 1/7. I can play matching games here. So x is going to be 1/7.